let's say we had a question like this. 5 over y minus 7 over y plus 7 over 2. Now, still an algebraic fractions question. First thing we'll have to do is find the LCM. Now, to find the LCM for this question, realize we have y, we have 2 as denominator. Now, y can go into y can go into y can't go into 2, nor does 2 can go into y. What we would have to do for this one, we would multiply 2 times one of these y, it doesn't really matter. So 2 times y would be the LCM. So y into 2y goes 2. 2 times 5 is 10 minus y into 2y goes 2. 2 times 7 is 14 plus 2 into 2y goes y, and y times 7 is 7y. So we would just simplify the numerator. That would give us our answer. So 10 minus 14 is minus 4 plus 7y over 2y. This would be our answer. Another one, let's look at another one. Let's say we had 2/3 plus a minus 2 over 2a. Now, like I did this one, 3 cannot go into 2a, 2a cannot go into 3, so the best option is to multiply both denominators to get our LCM. So 3 times 2a is 6a. Now 3 into 6a goes 2a. So 2a times 2 plus 2a into 6a goes 3. So remember, we could write the LCM as this also, or 3 bracket 2a. Probably you'd understand it this way. So 3 into 6a, 3 cancel 3, leaves the 2a. So 2a times 2. And then 2a into 6a, the 2a is going to cancel 2a, leaves 3. So it's going to be 3 times the numerator. So it's 3 times a minus 2. So 2 times 2a is 4a plus 3 times a is 3a minus 2. 3 times 2 is 6. So apply distributive law right here. 3 times a, 3 times minus 2, all over 6a. Now 4a and 3a is 7a minus 6 over 6a. This would be our answer. Let's see. Let's say we had 3 over y minus 2 over y minus 2. Now, remember, these are they're representing two different numbers, so we'll just multiply to get the LCM. So the LCM for this would be y times y minus 2. So y into the LCM goes y minus 2. Remember, the y is going to cancel the y, so we're left with 3 times y minus 2. Remember, after we set y into the LCM, multiply it by the numerator. So it's times y minus 2, and y minus 2 into the denominator goes y. So minus 2 times y. So we apply distributive law here. So 3 times y is 3y. 3 times minus 2 is minus 6 minus 2y, all over y times y minus 2. Then we would collect like terms and simplify. So it's 3y minus 2y minus 6 over y times y minus 2. Our answer, after we simplify this, 3 minus 2 is 1, so 1y, or y, minus 6 over y times y minus 2. That would be our answer. Now, our final question. This is an application question. What I mean by application question, we would apply factorization to solve this question, x squared minus 1. Now, we have x minus 1 and we have x squared minus 1 as the denominators of both fractions. Now, probably you would say, okay, so x minus 1, x squared minus 1 are representing two different numbers, so we could multiply them to get the LCM. No, in this case, it would be incorrect. What do I mean by that? This x minus 1, yes, it's different from x squared minus 1, but this x squared minus 1 has in it x minus 1. What do I mean? X squared minus 1 is difference of 2 squared. What do I mean by difference of 2 squared? This x squared minus 1 could be rewritten as x plus 1 times x minus 1. Let's see. Let's expand this and see if I'm correct. So we have x times x times minus 1, then we're going to multiply 1 times x, then 1 times minus 1. So we're going to have x times x squared, x times minus 1 minus x, 1 times x is positive x, and 1 times minus 1 is minus 1. So if you realize the like terms, they're going to cancel each other. So we have x squared minus 1. So in some cases, the CXC might set a question tricky like this one. So we have to really pay attention to the question. No one then, well, all the time. So the LCM is actually x squared minus 1. And how would I write this x squared minus 1? I would write it as x plus 1, x minus 1. X plus 1, x minus 1. So remember, this x plus 1, x minus 1 is actually x squared minus 1. And I did prove it on this side. So x minus 1 into the LCM. X minus 1 is going to cancel x minus 1 left, x plus 1. So it's 4 times this 4 times what is left, x plus 1. Bring back the minus sign. Now, x squared minus 1 into the LCM. Remember, x squared minus 1 is the same thing as this. So it goes 1 time. Understand? X squared minus 1 into x squared minus 1 goes 1. So it's 1 times 3, which would give us 1 times 3, which would give us 3. So we would expand the brackets. So 4 times x is 4x. 4 times 1 is positive 4. Rewrite the minus 3 all over x plus 1, x minus 1. So the like terms are already collected. So the answer for this one would be 4x plus 1 over x plus 1, x minus 1. So I'm going to do another question based on this application so that probably you can understand it a bit better. So let's say we had 2 over p plus 2 plus 3 over p squared minus 4. So remember, this p squared minus 4 sorry, p squared minus 4 is difference of 2 squared. Difference of 2 squared. How I could rewrite this p squared minus 1 minus 4 as p plus 2 p minus 2. In another video I'll show you how to factorize based on distributive law, factorization based on difference of 2 square, grouping, and also quadratic expressions. So remember, I can rewrite this as p plus 2 p p minus 2. So p plus 2 into the LCM goes p minus 2. So it's 2 times p minus 2 plus, bring back down this plus sign, p minus 4 into the LCM goes 1. So it's 1 times 3. So we have 3 here. Now we're going to use distributive law to expand the bracket. So 2 times p is 2p. 2 times minus 2 is minus 4. Rewrite the plus 3 all over p plus 2 times p minus 2. Would simplify the top, so it would be 2p minus 1 all over p plus 2 times p minus 2. So hopefully you understand this application type questions, and algebraic fractions doesn't give you any problems in the CXC exam if there's a question based on it.